Welcome, geometry students, to another mathematics Regents review video for the Geometry Common Core Regents exam. This is the August 2016 exam, and we are doing parts 2 through 4 in this video lesson. These are the open-ended short response questions. Just to give you a fair warning that this will take a while. This video will definitely be longer than the other ones, just because in geometry, the answer explanations are very long for the part 2s, and it requires a lot of work. Just to give you a fair warning, but this is the August 2016 Geometry Common Core exam, parts 2 through 4. Before we begin here, please refrain from cheating at all costs. If you are here, please leave if you were here because of cheating, because you have to do the problems on your own. You will not pass this Regents if you don't do the questions on your own. If you're here to check your answers or you need a little bit of guidance, you've come to the right place. All right, I am always here to help. And without further ado, let's just jump right into the part 2s. No fooling around here. Jump right into the part 2s. Let's get it on. So, question 25. It says, lines EA and BD are tangent to circles O and P at A, E, B, and D, as shown in the diagram below. If the ratio of AC to CE is in a ratio of 5:3, and the length of BD is 56, determine and state the length of CD. That's a lot of information. Let's break it down. All right, let's break it down. The length of BD, they tell us, they tell us that the length of BD, why does that keep doing? I want a pen. Thank you. That's equal to 56. And the ratio of AC to CE is in a ratio of 5:3. But remember, when you write a ratio, you have to put X's after those numbers because that is considered an unknown. Now, what does that tell us? We're trying to find the length of CD. We don't have that. Well, you need to know a circle theorem. And this is a theorem that's extremely important to get this question right. Tangents drawn from the same external point. So tangents drawn from the same external point are congruent. So if C is the external point, notice how AC and BC are drawn from the external point C, and they're both tangents. So therefore, if AC is 5x, then BC is also 5x. Same goes for CD. If CE is 3x, then CD has to be 3x as well. Now, this 5x and 3x kind of go away in the sense that we don't really need those anymore, because now we have 5x and 3x and 56. Now we can easily find x, because 5x plus 3x is equal to 56. So now let's go ahead and solve this equation. 5x plus 3x is 8x is equal to 56. Divide by 8 on both sides. You get x is equal to 7. Now, it's saying find the length of CD. Well, CD is 3x. So if CD is equal to 3x, we're going to substitute in the x value, which is 7, and we get CD is the length of 21. And that is the answer to question number 25. Moving on to 26. In the diagram below, triangle ABC has coordinates A11, B41, and C45. Graph and label triangle A double prime, B double prime, C double prime, the image of triangle ABC after a translation 5 units to the right and 2 units up, followed by a reflection over the line y equals 0. The first thing that we're going to do is we're going to translate it 5 to the right and 2 up. So let's do that right now. So I go to my graph, go 5 to the right, 2 up, 5 to the right, 2 up, 5 to the right, 2 up. So this is triangle A prime, B prime, C prime, okay? And I'm going to connect these points to create my triangle. Okay. Now the second part, which is probably the most confusing for students, is to reflect over the line y equals 0. You have to know what y equals 0 is. It is a horizontal line passing through all values of y equals 0. In other words, you are crossing or passing through the entire x-axis. So What that means is if I were to draw a line, this line that you see right over here, I'll just get a different color. This line that you see right there, that is the line y equals 0. Your job is to now reflect over that. So, since we're 3 away for A prime, B prime, since we're 3 away from here, we just go 3 below this line, draw, and this is 4 units down from here. So now this is C double prime, B double prime, A double prime. Ladies and gentlemen, you are done with this question. That was a pretty simple question. It's just a basic series of a sequence of transformations. All right, that's how you do question number 26. Number 27, a regular hexagon is rotated in a counterclockwise direction about its center. Determine and state the minimum number of degrees in the rotation such that the hexagon will coincide with itself. So you need to know a formula. 360 degrees divided by the number of sides is equal to the angle of rotation. Okay? So that is equal to 360 divided by the number of sides. Well, in a hexagon, there's 6 sides, and that will equal 60 degrees. Ladies and gentlemen, that is the answer to question 27. But I feel that if I just give you a formula and you just do it, then you don't know what that means. I now want to show you what this question is talking about. And if you want to skip ahead, that's fine, but I encourage you to just listen for a moment. Okay, so here I have a regular Here I have a regular hexagon, okay? So I'm going to actually shade in these hexagons different colors as red and blue. Okay, so here's what's going to happen. I'm going to put this up top. All right, so what the question's saying is how many degrees has to pass by for the hexagon to map onto itself? Watch what I'm talking about here. Here we have a blue hexagon. If I begin rotating it, you see how the red is now visible? The question's asking how many degrees do you have to go in order to not see that red anymore? And if you actually take a protractor, okay, and unfortunately you can't use this on your Regents, but if you take a protractor, I'm going to make this a little bit bigger, and you place it on one of the vertices, and you rotate it until you get to this side length, or this side over here, and you keep rotating it, and you line up with it, what does that number say? What is that number right there? It is 60. Oops. That is equal to 60. So therefore, we know for sure that 60 degrees is the angle of rotation that we need to map the hexagon onto itself. That's how you do question 27. All right, question 28. I just want to make this clear to you that immediately following this construction, there's a hands-on construction of me actually doing it with my hands and not my computer software. So if you like that better, you could skip this, fast forward it right now and go to that section of the video. Or if you want to watch both, that's perfectly fine with me. So 28 says, in the diagram of triangle ABC shown below, use a compass and straightedge to construct the median to AB. Do you want me to talk faster? Totally kidding. I talk way too fast. And it says, leave all construction marks. So it says construct a median. You have to know that a median is drawn to its midpoint. So what in the world does that mean? Well, if you actually take if you construct the perpendicular bisector of AB, you could construct the median. So that's what we're going to do right now. We're going to construct the perpendicular bisector. So what I'm going to do is I'm going to measure a little bit more than halfway and place my compass point on A. Measure a little more than halfway and construct your arc. And you're going to repeat the process on the other side. Okay? And there is your construction. Now all you do is you just take a straight edge and you line up these 2 points and you draw your perpendicular bisector, which looks just like that. Now, what does that tell us? Well, it tells us that this point right there, that's a midpoint, but we're not done yet. It's asking you for the median. Remember, a median is drawn to its midpoint, but what I should have really said is that a median is drawn from its vertex to its midpoint. So it's saying the median to side AB. That means that we're coming from point C and drawing to the midpoint. So this darkish purple line that you see here, this, ladies and gentlemen, is your median. Okay? All right, so the next part of this video is just me doing a hands-on construction. All right, so here's question number 28 from the August 2016 Regents exam. This is the construction, and this is the hands-on construction for those who do not like the computer software that I use. So the question says, in the diagram of triangle ABC shown below, use a compass and straight edge to construct the median to side AB, leave all construction marks. Now, a couple things that you need to know about a median. A median, once again, is drawn to its midpoint. It's drawn from the vertex to its midpoint. So it's saying draw a median to side AB. So the first thing that we need to do is we actually need to create a perpendicular bisector of AB. Now, in order to construct a perpendicular bisector of AB, I'm going to take my compass, place it on point A, and go a little bit more than halfway on this line. Then I'm going to construct my arc. There's my first arc, and then I'm going to repeat the process at B. Do not change your compass arm. It has to be the same. As you can see, these two arcs intersect each other. So what I'm then going to do is I'm going to take my straight edge, and I'm just going to connect these 2 points, just like so. Now it's asking you to construct the median. We have one more thing to do. It says the median to side AB, so it's being drawn from point C to line AB. So what I'm going to do is I'm going to place my straight edge on vertex C, and I'm going to create a line touching at its midpoint, because by definition, a median is drawn to its midpoint. So this line right over here that you see, this is the median drawn to side AB. And that is how you do this question. Okay, here's question number 29. Triangle MNP is the image of triangle JKL after a 120-degree counterclockwise rotation about point Q. If the measure of angle L, which is over here, is 47 degrees, and the measure of angle N, which is over here, is 57 degrees, determine the measure of angle M. So we're trying to solve for the measure of this angle over here and explain how you arrived at your answer. So, I want to talk about a couple things here. A rotation was performed, okay? So, triangle MNP is the image of triangle JKL, and it was rotated. That indicates to you that triangle MNP is congruent to triangle JKL. And that's because a rotation is a rigid motion which preserves distance and congruency. So these two triangles are exactly the same. Okay? So now what we're going to do is we're going to fill in our known angle measurements. Angle L is the same as angle P. So this up here is actually 47 degrees. There are 180 degrees in a triangle. Well, we're only looking at this triangle now. We don't care about this one anymore. Angle M is just figured out by doing 180 minus 47 minus 57, because there's 180 degrees in a triangle, which is 76. So the measure of angle M is equal to 76 degrees. So your answer is the measure of angle M is equal to 76 degrees. Now it says here, explain how you arrived at your answer. So you need to state something on the lines of this. Rotations are rigid motions. So angle measures are preserved. Angle L maps onto angle P, angle K, then maps onto angle N, and angle J maps onto angle M. Therefore, these three dots, by the way, mean therefore. Therefore, the measure of angle M is equal to 76 degrees. And that would be a good and proper explanation to prove why this angle is equal to 76 degrees. All right, and that's how you do question number 29. All right, next question. Number 30 says, a circle has a center of 1, -2, and a radius of 4. Does the point 3.4, 1.2 lie on the circle justify your answer? Okay, so they tell you what the center is, and they tell you what the radius is. It is your job to know what is the center radius form of a circle. Is this formula ringing a bell? X minus h squared plus y minus k squared is equal to r squared. That should be popping into your head right now. The center is 1, -2. Plug in that information. That's going to be x minus 1 squared plus y plus 2 squared. It's its opposites when it goes in. Is equal to, well, the radius is 4. 4 squared is 16. That's great. This right here is our equation of the circle. Now it's saying, does this point here lie on this circle? First of all, if you're thinking of graphing this, you are losing your mind. Do not graph this. You can't graph 3.4, 1.2 and know for sure that it lies on the line. You have to prove this algebraically. So your 3.4 is your x value and your 1.2 is your y value. So we're going to plug it into x and y. So we get 3.4 minus 1 squared plus 1.2 plus 2 squared, and that equals 16. So we get, all right, well, I'm going to plug this into my calculator right now. So we get 3.4 minus 1 quantity squared. By the way, I use the TI Inspire. If I didn't say that already, I think I did, though, in previous videos. But just in case, if you want this calculator, purchase it off of Amazon, and the link is on my website. So if we plug this information into our calculator, does that equal 16? And yes, it does. So since 16 is equal to 16, it's saying here, does it lie on the circle? Your answer is yes. 3.4, 1.2 lies on the circle. Now, what many students ask me all the time is say, well, Trevor, it says justify your answer. Don't you have to explain it? No. Justify means to show your mathematical reasoning or work. Explain means to use words. So the justification is this right here. So you're all done. Question 31. It says, in the diagram below, a window of a house is 15 feet above the ground, and a ladder is placed against the house with its base at an angle of 75 degrees with the ground. Determine and state the length of the ladder to the nearest tenth of a foot. So what we're doing here is we're saying, all right, let me draw a little stick figure, okay? And we're trying to find the length of the ladder. This long piece that's across from your right angle, that's the length of the ladder. I'm going to call that x. Now, since that's our x value, we now need to use trigonometry or SOHCAHTOA to solve for x. This 75 is your reference angle. This 15 is your opposite side. And this x is your hypotenuse because it is across from the right angle. So we are using sine because it has an O and an H in it. So the sine of 75 degrees is equal to the opposite, which is 15, over the adjacent, over the hypotenuse, which is equal to x. Put that over 1 and cross multiply. So we get x sine of 75 is equal to 15. Now we're going to divide by sine of 75 on both sides. And we get x is approximately equal to whatever that number is. So go to my calculator. I'm actually going to clear this out. Let me clear all this out. Control division, 15 over the sine of 75. And we get 15.5. The question says round to the nearest tenth of a foot, so x is approximately equal to 15.5, which is your answer. And that concludes the part 2s. Moving on to the part 3s. This is another construction. Again, if you want to see a hands-on construction, fast forward. I'd be happy to show you it that way. If you want to watch both, stick around and just watch this. Question 32 says, using a compass and straight edge, construct and label triangle A prime, B prime, C prime, the image of triangle ABC after a dilation with a scale factor of 2 and centered at B. Leave all construction marks. So, your job is to get a ruler and a straight edge. Okay? So, it says here it's centered at B. So that means if you go to B, you actually need to draw two rays extending from B. So this has to be a line from here to here. And the same process above it. So B has to be passing through this line over here as well. And this is my line extension. So I'm doing this. I'm doing this in order to. My apologies. I don't know why that did that. I'm doing this to create a bigger triangle. You need to dilate it by a scale factor 2. In other words, double the lengths of the sides. So you are going to place your compass point on B, measure to the length of point C, and you are going to draw a tick mark to measure it. You are then going to repeat the process without changing your compass setting and do it again. Okay? Now this point over here, that's now C prime. Now I'm going to go back to B and do it again at A. All right? You are going to then draw your tick mark, and then you're going to repeat the process over here. Okay? This point over here is now A prime. So now all that you do is you just simply connect point A to point C, and that, ladies and gentlemen, you just constructed your bigger triangle, which is triangle A prime, B prime, C prime. Now, before I go to the hands-on construction, it says describe the relationship between the lengths of AC and A prime, C prime. Well, A prime, C prime is the image. So we are going to say that A prime, C prime is double the length of AC. That's one acceptable answer, or you could say that AC is half the length of A prime, C prime. Either one of those would be acceptable, and that's how you do question 32. The next part of this video is the hands-on construction. Okay, so here's question number 32 from the August 2016 Regents exam. Once again, this is for people who do not like the computer software that I use and want to see a more hands-on application on how to complete this construction. So the question says, using a compass and straight edge, construct and label triangle A prime, B prime, C prime, the image of triangle ABC after a dilation with a scale factor of 2 and centered at B. Leave all construction marks. So basically we're trying to take this little triangle and we're going to dilate it or make it bigger by a scale factor of 2 centered at B. Now when it says centered at B, your job is to create two rays from point B. So I'm going to take my straight edge and I'm going to go from B and just extend a line outward. Just like so. So there's my first ray. Now remember that a ray is from a point and extends in one direction. And then I'm going to take my straight edge again and I'm going to place it on B, passing through in this direction. Now what your goal is to just dilate this by a scale factor of 2. But what does that really mean? Well, you're just going to double the length of AB and the length of BC. In order to do that, you need to take your compass and place it on B and touch at A. Your goal is to copy line segment AB. So what I just did is I just copied line segment AB. Using the exact same compass setting, I'm then going to place my compass point on A and then do it again. What this will do is it will create this point, which is now A prime. As you can see, it's being dilated by a scale factor of 2. Now we repeat the process for line segment BC. I'm going to place my compass point on B, measure the length to C, just like so. And I'm going to measure by drawing a tick mark at C. Now what I'm going to do is, using the exact same compass setting, I'm going to place my compass point on C and measure it again. And what this just did is it doubled this line segment. So now this point over here, this is now C prime. Now in order to complete the construction, your job is to simply just connect A prime and C prime. And this big, this big triangle that you see here was dilated by a scale factor of 2. I apologize about that little section over there. Now, there's a follow-up question down below, and it says here, describe the relationship between the lengths of AC and A prime C prime. This was just said previously in this video. All you need to say is that A prime C prime is double the length of AC. That's acceptable, or you could say that AC is half the length of A prime C prime. Either one of those answers would be perfectly acceptable. And that's how you do question number 32. Okay, so here's question number 33. The grid below shows triangle ABC and triangle DEF. So now it says here, let A prime B prime C prime, which by the way is not shown on the graph, but let A prime B prime C prime be the image of triangle ABC after a rotation about point A. Determine and state the location of B prime if the location of point C prime is 8, -3. Explain your answer. So, point C prime is 8, -3. So let's go ahead and graph it. 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2, 3. So this is C prime. Look at what happened, folks. This is now the line A prime C prime. Look at what happens. This is perpendicular to AC. So how many degrees did C rotate onto C prime? This is a rotation of 90 degrees. So therefore, the location of B prime must be 90 degrees. So the location of B, well, B is the point 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6, 7, 8. So this is 6, -8. So therefore, B prime must be located at the rotation of 90 degrees. So in order to rotate this 90 degrees, you flip the ordered pair and you change the sign of the first. So it's actually 8, no, I'm sorry. Oh, it's, you know what? It's rotated about point A. So we're just going to rotate it 90 degrees about point A. So all we do is we just say, hey, wait a minute. If B is 1, 2, 3, 4 to the right and 1 up, point B prime is up 1, 2, 3, 4 and to the left by 1. So therefore, this up here is going to be B prime. So I'm going to say here that B prime is located at the point, was that 7, 1? Yeah, 7, 1. And it says explain your answer. Because a rotation of 90 degrees counterclockwise about point A, point A was performed. And that's it. That's how you explain your answer. And let me just sketch this triangle just to make it look a little bit neater. All right, and that is B prime. Awesome. And that's how you do that part of the question. All right, moving on to the next part. It says, is triangle DEF congruent to triangle A prime, B prime, C prime? Explain your answer. So is this triangle over here congruent to this triangle shown over here? And the answer is yes, because if you actually look closely, there is a reflection over the line x is equal to -1. Oops. This is a reflection over the line x is equal to negative. This is so hard to move. I apologize. X is equal to -1. So we're gonna say yes, because a reflection over the line x equals -1 is a rigid motion which preserves distance and congruency. Now, I said this in past videos, and I want to make sure that I address it again. You are not allowed to say preserves size and shape. We are big boys and girls now. You have to say distance and congruency. It's not that size and shape is necessarily wrong. It's just that the Regents wants you to use mathematical vocabulary. So if you say size and shape, unfortunately, you do not get full credit on the Regents. That doesn't mean go tell your teacher saying that your teacher is teaching it to you wrong if they told you size and shape. It just means that the scoring rubric wants you to say distance and congruency. I know, I don't know why they want it, but you know, we have to deal with it. But it's really for mathematical vocabulary. All right, moving on to question 34. As modeled below, a movie is projected onto a large outdoor screen. The bottom of the 60-foot tall screen is 12 feet off the ground. The projector sits on the ground at a horizontal distance of 75 feet from the screen. Determine to say to the nearest tenth of a degree the measure of theta, the projection angle. So your job is to solve for that little theta right here. We have a problem though. That is not inside of a right triangle. So we cannot use basic trig in a one-time shot to solve for theta. We just can't do it. But we do have some bigger triangles to deal with. We have a big triangle here. We have a big triangle that is a right triangle. And we have a little triangle over here. Okay? So we could actually use this information to say, hey, wait a minute. I could solve for this big angle. I'm going to call this big angle that you see, I'm going to call it alpha or A. And I'm going to call this angle inside here, I'm going to call this beta. Okay? And if you can't see that, I'll just make it a little bit better. We're looking for the yellow angle, and we're looking for the orange angle over here. Okay? So your job is to use right triangle trigonometry to get this. So the first thing that I'm going to say is I'm going to say solve for alpha. And I just call it alpha. You don't have to say alpha. I just like calling it that. Okay? So we are using tangency. By the way, the addition of 60 and 12 is 72. That's important because that's the whole side of the blue triangle. So we have the tangent of alpha is equal to the opposite side over the adjacent side. Okay? Because we don't have the hypotenuse, so we're forced to use tangent. So the tangent of alpha is equal to the opposite side, which is 72, over the adjacent, which is 75. Now, to solve for alpha, we take the inverse tan of 72 over 75. Now we go to our calculator, and we take the inverse tangent of 72 over 75. And we get 43.83. Which is okay, so we put that 43.83. Now, what we're going to do is we're going to solve for beta. And that's the little triangle. So again, the tangent of beta is equal to the opposite over the adjacent. Okay? The tangent of beta is equal to the opposite, which is 12. So now it's the little triangle. We're looking at 12 and 75. So now we take the inverse tangent of 12 over 75, which is approximately equal to 9.09. So now in order to solve for the theta, the little angle that you see there, in order to solve for theta, we need to take 43.83 and subtract the little angle, which is 9.09. When you do that, theta is going to equal 34.7 degrees. So that is the answer to question number 34. And that, ladies and gentlemen, is the conclusion of the part 3s. Now we're going on to the part 4s. And the part 4s on this exam, the first one was kind of tricky. The second one was not that bad. So this is a circle proof. Given circle O, chords AB and CD intersect at E. And it states a theorem. The theorem states if two chords intersect in a circle, the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Prove this theorem by proving AE times EB is equal to CE times ED. Okay. I don't think that many teachers cover this anymore. This down here is actually something that's called the product of the means is equal to the product of the extremes. This really isn't taught anymore. I learned it when I was in geometry a very long time ago, but I think some teachers still teach it to you. But if you didn't know that, welcome to the product of the means equals the product of the extremes. So your job is to prove that these two triangles are congruent. Whoa, Trevor, what are you talking about? There's no triangles there. What are you talking about? You need to create your own triangles, and you need to prove them similar. So we have to say that CB and AD are drawn. Now we have triangles. So we have to prove triangle CBE similar to triangle ADE by angle-angle similarity. How do we do that? Vertical angles are congruent, and these angles up here are going to be congruent as well. And I'm going to talk about that in just a few moments. So let's go ahead and start the proof. Number one, I'm going to say that circle O, chords AB and CD intersect at E. And your reason is given. Now, number two, we now need to state that we just drew similar triangles. So I'm going to say that chords AD and CB are drawn. And your reason is kind of interesting. Auxiliary lines. Yeah, I know. That's kind of a weird tongue twister. Are drawn. Or in other words, random lines are drawn. But auxiliary lines are drawn. Alright, so now I'm going to go on to number three. Angle C is congruent to angle A. Now, these are congruent because of the reason that is derived from circles. Inscribed angles that intercept the same arc are congruent to each other. Okay? So that proves those two angles similar. I'm sorry, congruent, I should say, congruent. Now, number four, I'm going to state that the vertical angles are congruent. I'm going to call this angle 1 and angle 2. So angle 1 is congruent to angle 2, and your reason is vertical angles are congruent. All right. Now, number 5, I can now prove these two triangles to be similar to each other. So triangle BCE is similar to triangle DAE, and your reason, oops, that's not a 5. And your reason is that angle-angle is congruent to angle-angle. So now we just proved these two triangles similar. Now it's time to prove the theorems that they want us to. So number 6, we are now going to say that AE over CE is equal to ED over EB. And the reason why I'm saying this is like, where did that come from? The reason why I'm saying this is that these two triangles are similar. And that's a ratio. This right here, this is a ratio, or it's also a proportion. Ratios are proportions. So I'm going to say CSSTP. Now, if you never heard of it, that stands for corresponding sides of similar triangles are in proportion. Okay? Corresponding sides of similar triangles are in proportion. It's just one of those things that you might have overlooked this year, but you definitely did learn CSSTP. Now, last but not least, number 7, we're trying to prove the theorem. I'm going to say that AE times EB is equal to CE times ED, and your reason is in a proportion. Oops. in a proportion, the product of the means is equal to the product of the extremes. And you're done with that proof. All right, so that's actually, I mean, it's really not that bad of a proof. If you had some experience with circle proofs before. If you didn't, then this was like a total, like, it was definitely a different proof for you. But that's how you prove it. It's really not that bad. And now let's go on to the final question of this exam. And it's my favorite snow cone question. A snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice as shown in the diagram below. The inside diameter of both the cone and the hemisphere is 8.3 centimeters. The height of the cone is 10.2 centimeters. The desired density of the shaved ice is 0.697 grams per cubic centimeter. In other words, the density of the shaved ice is 0.697. And the cost per kilogram of ice is $3.83. Determine and state the cost of the ice needed to make 50 snow cones. Okay, so first and foremost, we need to find the volume of this whole snow cone for one snow cone. It's the volume of the cone, which is here. It's the volume of the cone plus the volume of the hemisphere. We have to add those. So let's do that right now. So the volume of the hemisphere is going to be 4/3 pi r cubed. However, that's a volume formula for a sphere. A hemisphere is 1/2 of a sphere. So this we have to multiply by 1/2. Just keep that in mind. So the volume of this hemisphere is equal to 4/3 pi. Now the radius is just 8.3 divided by 2. That would be your radius. It's your diameter divided by 2, raised to the third power, and multiply this by 1/2. I'm going to go right to my calculator, and I'm going to plug in this information. So 4/3 times pi times my radius, which is 8.3 over 2 quantity to the third. And all of this is being multiplied by 1/2. I'm getting 149.693. 149.693. Now I need the volume for the cone. So the volume of a cone is just 1/3 pi r squared times the height. So the volume of the cone is equal to 1/3 pi times the radius, which is again 8.3 divided by 2 squared times the height of 10.2. Again, go right to your calculator. 1/3 times pi times the radius, which is 8.3 over 2 quantity squared times the height of 10.2. And we get 183.961. 183.961. When we add these together, the volume of the whole snow cone, so the volume of the snow cone is equal to, well, let's go back to our calculator and let's add this. Enter. Oops, forgot the plus sign. Plus this. 333.65. 333.65. 333.65. That's the volume for one of the snow cones. Now, it says here, how do we make 50 of the snow cones? So what we have to say is, all right, wait a minute. We have to take 333.65 and multiply it by 50 of them. And this will give us the total volume. And that will give us, let's see, go back to my calculator. Okay, sorry about that. So it's 333.65 times 50 of them. And that gives us 16,682.707. So go back here, and we get 16,682.50. No, I'm sorry. 1662.70. My apologies, 70. Okay, 70. So now what we have to do is we need to take this number right here and we are going to multiply it by 0.697 grams per cubic centimeter in order to find the cost. Now, real quick, this is your volume, right? What is this? That's your desired density. Remember what I said to all of you in every video? Weight is equal to density times volume. We need to use it here as well. Weight is equal to density times the volume. So the weight is equal to the density, which is 0.697, times 16,682.70. And when you plug that into your calculator, you get 11,627.85. So weight is equal to 11,627.85. Now, we now need to find the actual cost of this. The cost of per kilogram is $3.83. So what I'm going to do is I'm going to take my weight and I'm going to multiply it by $3.83. But ladies and gentlemen, we have a serious problem. And it's right here. This unit of weight is in grams because your density was in grams. They're asking you for kilograms. Kilograms. You should remember from science class or maybe geometry class, I'm not so sure, the acronym King Henry drinks ultra dark chocolate milk. Your U is your unit measure. In this case, it's a gram. Kilograms is the big K over here. So we need to convert grams to kilograms by moving the decimal place 3 times to the left. So your weight in kilograms is 11.62785. So now I'm going to take 11.62785 and multiply that by $3.83. Okay, so now I'm going to take that number, 11.62785 times $3.83. It's going to cost you $44.53. $44.53 to purchase the well, that is the cost of making 50 snow cones. And that, ladies and gentlemen, is how you do question number 36. All right, I hope that this helped you. Please make sure to subscribe to this YouTube channel for a lot more math content. And please visit my website at www.nysmathreadersprep.com. Great job, and I hope to see you soon.